Algebra 2. This is lesson 34A, and remember there will be no lesson 34B. This is our last tape. This is part 2, and we are continuing with our final exam review. Now this is a new section, and we're talking about negative exponents. Some of you were kind of weak on this, so we want to review this idea carefully. A negative exponent means to put it across the division line. Okay, so what do I mean by that? Well, if I say a squared x to the negative 3, let's not say that yet, sorry, x over b cubed y squared, and I say write it without a denominator. I want to move that to the numerator, that to the numerator, and the way I do that is by making them negative exponents. So we would just typically write in alphabetical order, then comes the b, not to the third power, but to the negative third power. Then comes the x, which is already in the numerator, so I don't change it. Then comes the y, not squared, but to the negative 2 power. So when I am looking at negative exponents, I mean if I were to write them positively, I would take them across the division line. All right? So these two things are equivalent. They're just written in different forms. Now let's look at another. What if I said this? I want to say write it without a denominator, so this needs to go up. If I'm moving across the division line, I am going to change this to the opposite sign. Okay? Move it from the numerator to the denominator, denominator to the numerator, change that from a negative exponent from a negative to a positive. That's really all there is to it. It's not a hard idea, but some of you kind of got a little bit confused. So what if I instead had something like 3, a to the negative 4, b to the negative 2, and I said write it with positive exponents. Okay. What would I do there? It means if it's got a negative exponent, I've got to take it to the denominator to make it a positive exponent. So that is the same as 3 over a to the 4th b squared. What if I said write it without a radical sign? They're different ways of meaning the same thing. Okay? If I say the square root of x y to the 3rd, and I say write it without a radical. Well, the radical is going to convert to a denominator in a exponent. So across the division line converts to a negative or positive in the exponent. A radical sign converts to a denominator in the exponent. So that is the same. If I want to take this away, the radical sign, I have to say x to the 1/2 and y to the 3/2. If instead I had, let's subtract this out, and instead I had put a cubed here, this would be x to the 1/3, y to the 3/3, or y to the 1st power, or just leave it as 1. Okay? Makes sense? If I instead had, one more time, if I had this instead, I would say x to the 1/5, y to the 3/5. Okay? So a radical index converts to a denominator. What else? If I have x squared times x to the 5th, what do I do? Add exponents. We should already know that, right? So this just becomes x to the 7th. So what if I had x squared times x to the -3? What do I do? It's the same thing. I'm multiplying, so I'm adding exponents. 2 minus 3 is x to the -1. if I had, I might get that a little more complicated. Let's say I had 2x squared y to the negative 3 times 5 x to the negative 4 y to the negative 2. I'd multiply. I'd add exponents for my x. I'd add exponents for my y, and that's my answer. Or, if I said don't have negative exponents, I would have to do what? Put those into the denominator without the negative sign. Either way, whatever I give you directions to do. So fractional exponents, let's review this just a little bit more because, again, you were struggling. Some of you were struggling with this. Okay, a fractional exponent. X to the 3/5 is the same as x to the 3rd to the 5th power, right? If I had by the way, let's say if I had this, if I had x to the 2/5 raised to the 4th power, what do? We multiply. Equals x to the 8/5. Let's see here. I think I've kind of covered that part. Okay, so again, go to that section and practice. Now, scientific notation is really a fairly straightforward idea, but some of you missed a little bit of this, and then it threw you off. Okay, the general form for scientific notation has to be one place value with a point. Then it could either be nothing to the right of the decimal point, 2 numbers to the right, 3 numbers, it doesn't matter, times 10 to an exponent. The exponent could be positive or negative. So, an example would be 3.17 times 10 to the 4th. That's a good scientific notation. Or 3 times 10 to the negative 5. That's okay. You don't need to put the point there as long as you just have a whole number. That's fine. But if I have 37 times 10 to the 3rd, that is not scientific notation. And if I have, I guess that's the real one we're worried about. Okay, so let's talk about converting. We can convert from scientific notation to a regular number. And I would say it's going to be a smaller number. My decimal right now is not written, but it's right to the right of the whole number. So I need to move it to make a smaller number. I need to move it to the left 3 places. To the left, okay, 1, 2, 3. See how I've moved that 3 places? And that's converting from scientific notation form to regular number form, or we would say expanded form. Let's do it again. What if I had 2.93 times 10 to the 7th power? My decimal point is there. You're always moving your decimal point. I wanted a larger number, and I need to move it over 7 places. Well, there's 2 places, so I need 5 more places. So that becomes 293 and 5 more places. That would be 5 more zeros. 1, 2, 3, 4, 5. Put your commas in, and that's your answer. Go back to this section to review it if you need to. Now going the other direction, if I have 0.00319 and I want to go to scientific, put your decimal there. 3.19, because you only want one number to the left of the decimal, times 10 to the what? How many places over did I move it? I moved it over 3 places, and but it's a small number, right? So I needed a -3. If I have a large number, 768400000, that's going to be 7, put the decimal right after the first value. 684, how many places did I move it? It's a large value, so I need a positive, and I've gone over 3, 6, 8. Review it if you need to. Okay, that's scientific notation. We'll have a couple going in each direction. Write as a radical. I've already talked about that. Reduce to simplest form. Make sure. Let me do one more thing in that. Okay, a little bit more complicated than what we did before. Now remember, 32 is 2 to the 5th. Okay, so here we're going to divide out just like we did, but they won't all come even. I'm going to divide by 4, and I'm going to get one group of 4. Okay, 5 divided by 4. Right? I've got one group of 4 and a remainder of 1. So I'll pull out one group of 2's, and under the radical I still have 1, 2. To divide by 7, or 7 divided by 4, goes in one time, and I have 3 left over. This goes in one time, and I have none left over. So my answer is this way. Now here's another way you might like doing that, if that's not comfortable to you. 32 is 2 times 2 times 2 times 2 times 2. I need every group of 4 can pull it forward. So this is 2, the 4th root of 2. I can do the same with my x's. 1, 2, 3, 4, 5, 6, 7. Every group of 4 can pull it forward. Okay, it will be out of order here, but that's all right. And then how many are left over? 3. Okay, so you could do something like that instead. Okay, same order. When we're talking about radicals, radical signs. This means the same index. Okay, this is an index of 2. You might want to write that in there. And this is an index of 3. My common index would be 6, just like a least common denominator. Okay, so this will have to be to the 6th, and this will have to be to the 6th. Now write down anything under that can be simplified with exponents. And now for the next step, I'm saying, okay, 2 times what is 6? That'd be 3, so I'm going to cube it. 3 times what is 6? That would be 2, so I'm going to square it. Now clean them up a little, and if I'm writing these two things in the same order, I'm going to get the 6th power of 27 and the 6th power of 4 times 4 squared is 16. Okay, so go review it if you need to. That's writing to the same order, radical expressions. Otherwise, when I'm multiplying radicals, I might have 4 the square root of 8 times 6 the square root of 5. And I would multiply my whole numbers, and I would multiply my radicands. Then I would simplify. I could simplify before, but it might just be easier to simplify afterwards. 40 is the same as 4 times 10, which is the same as 2 times 2 times 2 times 5. If it's the square root, I'm looking for every group of 2. So now we have 2 times 24, or 48, the square root of 10. Again, if you're not comfortable, make sure that you go back and review. When we're adding, we can only add if we have the same index. This is a square root. This one's going to be a square root. Oh, let's say we're going to have, I'll change this up a bit, minus 3, the square root of 32. So I have to simplify this and simplify this, and then only can add or subtract if I get the same number under the radical. Okay. 18 is 9 times 2, so the 3 can go forward, and this becomes 15. 3 times 5 is 15, square root of 2. Oh, let's see, 32 is going to be 16 times 2. So that could take a 4 forward, minus 4 times 3 is 12, square root of 2. Now, only because these have the same radicand, or number under the radical sign, then I can say 15 minus 12 is 3, and leave the radicand alone. So this is addition and subtraction. Okay, has special rules like it always does, because you need like terms to add and subtract, whereas the one above was multiplication. Right? Okay, a couple more ideas. This is simply going to be FOIL, and because they're the same terms, 2, 7, square root of 3, okay, and the only thing that's different is my plus or my minus, my middle terms drop out. So FOIL, I'm really just going to look at the first and the last terms, because we call these conjugates, remember that? Okay. So 2 times 2 is 4, and 7 times the square root of 3 is going to be 49, because the 7 times 7 is 49. It'll be subtraction. 49 times square root of 3 times square root of 3 is 3. So this will be, let's see, 3 times 9 is 27, 12, 14, or negative 143. Review that if you need to. If I had the same the same index, let's say here. If I had the same index, that's the same index, there we go. I can write that as 1 and simplify it that way. Because I don't have at least 3 of these, I can't. This is only going to be 3 times 3 and not 3 times 3 times 3. I can't simplify that any further. Let's talk about how we would solve equations. Now, you tended to be good at this. Let's see. Isolate your square root. So that means I'll take this to the other side by subtracting. Square both sides because it's a square root, and I'll get x, because the square root of x times the square root of x is simply x. I could even look at it this way. It's that, and then I'm looking for any pair of 2, right, to go forward. So that's x. 3 squared is 9. Let's practice another one together. If I had x minus 4 plus 2 equals 7, isolate the radical by subtracting 2. Square both sides. Again, when you square a radical, square root, right, with a 2 here, or nothing, which means a 2, you get x minus 4 equals 5 squared, or 25. Add, and you're going to get x equals 29. Okay, next idea, imaginary numbers. By the way, I only have 2 problems with imaginary numbers. So if you find these difficult, that's okay, just skip it. Okay, but I will review. If I have the square root of negative 16 plus the square root of negative 25, I have to, a square root of a negative is I. This is the same as 4I. This is the same as 5I. If they have the same thing there, then that's just 9I. Okay. If I instead have square root of negative 16. Let me get that erased here. Try it again. Times the square root of negative 16. This is the same as 5I times 4I. That's 20I squared. And I squared, you have to memorize this, equals negative 1. So that's negative 20. If I have the square root of negative 1 to the 12th. Okay, a square root of negative 1, you have to memorize this, is the same as I. That's I to the 12th. Now, I know I squared equals negative 1, so convert this from a single number to I squares. Well, that's I squared to the 6th power. That's the same as negative 1 to the 6th power. A negative to an even power is positive. That's the same as positive 1. Now, if you don't want to learn that, just skip it, because there's only 2 points that are writing on it. But if it was fairly easy and you just got a little confused, go ahead and learn it. Okay. Now, we have at the end here, we have solving quadratic equations. Now remember, quadratic means you have a squared term. So if I have x squared equals 16, okay, I'm going to take the square root of this side and the square root of this side. That becomes x equals, and there's going to be 2 answers. So here I'm not just talking about the principal. This will be plus or minus 4. If I had 3x squared minus 25 equals 0, take this to the right side by adding 25. You get 3. Oh, let's do 75. Okay, let's add that to the right side. That's 3x squared equals 75. Divide by 3. That's x squared equals 25. Take the square root of both sides. You'll have 2 answers. And by the way, I give you that hint that you'll have 2 answers. So x equals the square root of 25 is 5 plus or minus 5. If you have 3 terms with a quadratic, it would look like something with both an x squared I would take everything to the left side, so I would add 11x and put it in my proper order. And then I would try to solve this another way. I can't divide everything by a common factor, so I would try binomial factoring. Okay. Let's see. I'd have to have 2x and x. 2 times, let's see, it'd be 14, but I'm multiplying by the 2 here. That'd be 28. What are 2 numbers that multiply together to give me 28 and sum together to give me 11? That would be a 7 and a 4. Okay. So let's go ahead and try that by foiling backwards to check yourself. 2x times x is x squared, 2x squared. Outer would be plus 8x. Inner would be plus 7x. That's 15x. I didn't do that right then. Hang on a second. See, this is why you want to always solve it or foil it back and check yourself. Okay, it's been a while since we've done this with a number in front of the first term. So remember, we have to factor those and we have to factor these. And now we're looking for the combination that's going to give me 11 as my middle terms. So if I put the 1 and then the 2, I'd multiply 1 times 1 is 1. Do you know what I'm doing here? I've got 1 and 2 and 1 and 14. I could combine it this way. That'd be 28 and 1. That doesn't work. Or I can combine it this way, and I get 14 and 2. And I'm looking for a sum of 11, and that doesn't work either. So now I'm going to take 1 and 2 and 2 and 7. If I do it this way, I'm going to get 4 and 7. That works. Okay, if I did it this other way, I get 2 and 14, and that does not work. So this is the only one that works, is the 1 goes with the 7. So there's my 1, and so it's got to go here with the 7. And this one's got to go with the 2. The 2 and the 2 go together. Okay, now foil it and check it. 2x times x is 2x squared, outer is 4x, inner is 7x, and there's my 11x, and the last one, there's my 11x, and then 2 times 7 is 14. So that's the way it works. Now, we're not quite done, so let's review how that last part works. Again, you factored that to 2x plus 7, and x plus 2 equals 0. So one or the other has to either 2x plus 7 equals 0 or x plus 2 equals 0. Solving for x, you get 2x equals negative 7 or x equals negative 7 halves or x equals negative 2. Remember that? So you might want to check out a couple of problems like that to give yourself some more practice. Now, you also want to be able to, moving on to the next page, you want to know the quadratic formula and you want to be able to use the quadratic formula. By that, if I had 3x squared minus 7x plus 2 equals 0, I would identify A as 3, B as negative 7, C as 2, and I would plug all that into the quadratic formula and solve it. Review it if you need to. The last thing would be to solve quadratic by completing the square. And actually on the quiz, you guys were really good at this. So let's review that. What I would do here is I'd take half of that, and so it would be x plus 9 squared, and then I would multiply, half of that, square that back, add 81 to both sides. Remember how that works? And then you would go 81 minus 3 is 78. Square both sides. I'm sorry, take the square root of both sides, and you get x plus 9 equals the square root of 78. Two values, always two values when you're solving for an x squared. And this isn't going to come out very even, but you would just say, in this case, minus 9 plus or minus square root of 78. Okay. Let's see, another word problem, and then the extra credit. There's 5 extra credit questions. If you wanted to solve something, for instance, that was x minus square root of x plus 7 equals negative 1. I would take this to the other side by subtracting. Equals negative x minus 1. I would take this to the other side by multiplying by negative. Distributing that negative. I would square both sides. This would become a trinomial, remember, with FOIL. Okay. And then I would gather my x terms. Well, let's go ahead. Plus x, that would be plus 2x plus 1. And then I would take everything to the left, or everything to the right, so I'll keep it positive. X squared, 2x minus x is plus x. 1 minus 7 is minus 6. And then go ahead and solve that. That you can solve easily. So this is a little bit of a tricky one. Okay, couple more extra credit ideas. Don't forget how to convert to log form. Let's say if I had to the 4th power, that would be 16, right? And so if I wanted to write that to log form, I would say log to the base 2 of the answer equals the exponent. Just a memorized form. This is extra credit. I would want you to be able to go back and forth to get some extra credit points. By the way, 2 to the 5th equals x. I want to write that in log form. Log to the base 2 of x equals 5. This is always the exponent. Okay? So you know you're on the right track. What if I had, let you solve it, something. Let's say if I had 2 to the x equals 64. I'm saying 2 times 2 times 2 times 2, how many times equals 64? And there's a couple ways you can do that. You might just know the answer. I know the answer. But if you don't, what could I do? I could say, okay, well, 64 is 8 times 8. 8 is 2 times 2 times 2. times 2 times 2 times 2. How many 2's did I have? 6. So x would equal 6, something like that. Okay? So I think there are, if you understand how exponents work, you might be able to solve those, okay? But I'm not going to go over any more of that. I think we've pretty much nailed it, guys. This is the final exam. I've gone over one of basically each type of problem. I haven't worked all the specific problems, though I've worked a few of them, but I've changed the numbers around and given you examples of each type of problem I'm going to hold you accountable for. I think if you know all this stuff, you've got a pretty good handle on Algebra 2. There are a few concepts that are typically done in an Algebra 2 class that we did not get to, but they are towards the latter part of the book and it will always be reviewed in a pre-calc class. So I feel great about the program, and you know exactly what you need to study, and I'm going to be praying you all do just a wonderful job on your final exam. God bless you, and know that I also am praying for you for this summer and expecting to hear a wonderful report on how each one of you grows, matures, and learns things this summer, as well as just seeking to be a blessing to those around you. God bless.